We've all seen the demo. You type a single, massive prompt into an AI, sit back, and watch as it supposedly builds a complex software project from scratch. It's a compelling idea, a solitary superbrain doing everything at once. But in practice, that approach collapses. As the AI works through a long task, its finite working memory, the context window, fills up. It dumps code snippets, web searches, and raw files into this shared space until it physically runs out of room. When that happens, the model starts to hallucinate, distort its instructions, and eventually crash. We call this context bloat. The instinct is to simply buy a bigger bucket, to use models with massive context windows. But forcing an AI to hold everything at once makes it lose focus. It gets distracted by stale code or tangled in off-topic details from a previous search, slowing down its reasoning until the system freezes entirely. The solution requires an entirely different approach. We need an agent harness, a framework that enforces strict organization rather than just throwing more raw memory at the problem. To maintain performance across complex projects, we have to move away from the solitary worker model in favor of a structured, delegated architecture. Imagine asking an AI to build a multi-source data analysis app. Instead of loading every possible instruction up front, a deep agent begins with a pristine workspace. It uses a technique called progressive disclosure. The agent checks its core rules, reads a lightweight index of its available skills, and pulls in only the exact capabilities it needs for this specific task. The rest of the library is ignored, keeping the working memory entirely clean. At this stage, the agent isn't a coder, it's a supervisor. It uses a built-in planning tool to break the complex app into a discrete step-by-step plan. It maps out exactly what needs to be done, creating a roadmap for specialized workers. By acting as a project manager and planning first, the supervisor avoids loading any intermediate data. It maintains complete strategic clarity before a single line of code is written. With the plan set, the supervisor delegates the heavy lifting. It spins up sub-agents, specialized workers like a dedicated researcher or a focused coder, to handle the actual execution. These sub-agents don't work in the main memory space. They are dropped into secure, wall-dive sandboxes. Here, they can safely execute shell commands, scrape websites, and write code in total isolation. Even specialists generate messy data, but sub-agents manage their own localized bloat. They summarize older messages and offload massive files to a virtual file system. They leave behind tiny reference pointers in their active memory, ensuring they never overflow their own capacity. This architecture enforces context quarantine. The chaotic, data-heavy trial and error of building software is trapped within the sandbox. The supervisor is shielded from the noise, preventing the system from collapsing under the weight of its own intermediate work. This isolation also enables a critical safety layer. Before a subagent runs a destructive command, like overwriting a vital system file, the execution halts. A human user steps in to review the proposed change. This approval step bridges the gap between the speed of an autonomous agent and the absolute necessity of human oversight. Once the task is complete, the delegation protocol concludes. The subagents shut down, destroy their messy workspaces, and return only the final, polished result back up the chain to the supervisor. The supervisor receives the answer, completely blind to the messy math used to get there. Strictly controlling this upward flow of information is the only way to reliably scale complex AI execution. For a true deep agent, the job doesn't end when the code is deployed. After the active workflow finishes, the agent enters a phase of background consolidation. The agent processes semantic memory, extracting learned facts to update a permanent profile. It also writes to episodic memory. The successful action sequence is captured as a historical template, allowing the agent to solve similar problems faster next time. Reliable autonomy requires an architectural capacity to learn from past experiences to optimize future performance. The model of using a single, overburdened brain to process every detail simultaneously reaches a ceiling as tasks grow more complex. Sustained AI performance relies on clear structural pillars, separating coordination from execution, isolating context into dedicated quarantines, and persisting knowledge through structured memory. Scaling artificial intelligence relies on building architectures that mirror human organizations,
rather than chasing monolithic models with infinite memory.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.